Okay, continuing on practice problems in section 12.6, other coordinate systems. Next up is question number 7, which asks, find the plane y equals 0 in spherical coordinates. Well, the conversion for spherical coordinates is that rho sine of phi sine of theta is equal to y. There are other conversions, but of course, this one doesn't put any limitations on x or z, so we don't need those conversions. So it looks simple that the equation will simply be rho sine phi sine theta equals 0. But that's actually a little bit of overkill, because it turns out that this represents the zero product rule. The product of rho sine phi and sine theta will equal 0. Turns out that rho will never be responsible for this being 0 except at one location, and that's the origin. This point does contain the origin, the point 0, 0, 0. But rho is only 0 at that location. Other than that, rho represents the distance from each point in the plane to the origin, and of course it's only at the origin that it'll be 0. So rho is not responsible for this being 0. We can actually drop it out of the equation. Rho cannot be 0 in general. It's only 0 at one particular point. So that leaves us with sine phi sine theta equals 0. Of course, phi is the angle that rho makes with the z-axis. And this plane, which encompasses the entirety of the xz plane, will feature plenty of times that rho is tipped at an angle to the y-axis. So once again, sine of phi being equal to 0 only occurs at one time, and that's when rho runs along the z-axis. All other points that rho points to, sine of phi will not be equal to 0. So in general, sine of phi is not equal to 0. Well, that leaves us with sine of theta equals 0. Well, let's examine all the points that satisfy this. In 3D, what we're basically talking about is all the points where y equals 0. Well, that's every point in the xz plane. So it'll be all of these points stretching in both directions. It'll basically make a wall in our 3D plane. So that's the plane we're talking about. Well, let's examine what theta represents. Remember, theta represents the angle to the point that lies in the xy plane. And of course, that will only be angles that are along the x or the negative x-axis. That would be angles of 0 or 180 degrees. And you notice in both cases, the sine of those angles will be 0. So this turns out to be it. This is the only condition we have to meet in order to plot every point on the plane. So don't be fooled. Just because you've converted it doesn't mean that formula is correct. You have to check points that lie in the new figure and ensure that you don't have overkill. You don't have portions of the formula which are simply unnecessary because there's no restrictions. There's no restrictions on the value of rho. All values work. There's no restrictions on the angle phi. All values for phi work. The only place there's restrictions is on sine theta. Sine theta must be 0 because theta itself must be 0 or pi or some multiple thereof.